This is the story of Starship, the boldest and most powerful rocket humanity has ever built. SpaceX's Starship program has faced fiery explosions and technical problems. Each setback fueled skepticism, and every challenge, from technical failures to bureaucratic hurdles, seemed insurmountable. But then SpaceX did what it does best. It adapted, improved, and turned doubters into believers, rewriting the rules of spaceflight. The origin of Starship dates back to 2015, when Elon Musk mentioned the Mars Colonial Transporter, a huge vehicle for transporting people to Mars. At that time, SpaceX was already developing the Raptor engines, crucial for any large spacecraft. These engines used full-flow staged combustion cycle, an unprecedented and complex method involving 2 independent turbopumps and 2 smaller chambers to maintain system pressure. Despite industry skepticism, the Raptor worked, powered by liquid oxygen and methane, providing more efficient combustion than traditional kerosene. Starship, initially known as the Interplanetary Transport System, ITS, was announced in September of 2016. Measuring 401 feet in height, 39 feet in diameter, and weighing more than 23 million pounds, the ITS would be capable of carrying almost 660,000 pounds to low Earth orbit, or more than 1,200,000 pounds if discarded after use. Its goal was to transport large cargo or people to Mars with the capacity to put almost 1 million pounds on the red planet. Construction involved carbon fiber, a challenging and expensive material, and SpaceX tested a huge liquid nitrogen tank to understand structural limits. The ITS would require 42 Raptor engines for the booster and 9 more for the spacecraft, generating a thrust of more than 28 million pounds, 4 times more than the Saturn V. With a fully reusable design, both parts of the vehicle would land vertically, using technologies similar to those of the Falcon 9. The project also envisioned a tanker version of the ITS, capable of carrying more than 838,000 pounds of propellant to orbit, refueling other vehicles for distant missions such as Mars. With this, Starship symbolizes a milestone in space exploration, opening paths for interplanetary travel. At the International Astronautical Congress of 2017, Elon Musk announced an update to the spacecraft, renaming it as Big Falcon Rocket, or BFR, a more modest designation compared to the initial ambitions. The BFR was 348 feet tall and 29 feet in diameter, with 31 engines in the first stage. Its capacity was to transport more than 330,000 pounds to low Earth orbit in reusable mode, surpassing existing vehicles at the time. The BFR spacecraft featured solar panels near the engine section and a cargo door that opened and closed during the mission, allowing the release of satellites. A notable feature was a small delta-shaped wing at the bottom, facilitating atmospheric re-entry, but with limited control. In 2018, during the announcement of the Dear Moon mission, SpaceX revealed a new version of the BFR. This version included 3 landing supports, reminiscent of spacecraft from comic books, but with a futuristic design. It had 4 Raptor engines optimized for vacuum and 3 for sea level, plus 2 upper flaps to assist in aerodynamics. A heat shield at the bottom used an active cooling system, with propellant circulating between the fuselage and thermal protections, allowing re-entries into the atmosphere at high speeds. The most significant change was in manufacturing, with the replacement of carbon fiber by stainless steel. Despite doubts about the strength of the material for such a large vehicle, stainless steel was cheaper and its rigidity increased at low temperatures. This was suitable for liquid oxygen and methane tanks. This new design promised launches for less than $5 million. Finally, the vehicle was renamed as Starship for the spacecraft and Super Heavy for the booster. The Starship now had 3 Raptors for sea level and 3 for vacuum, with the capacity to carry more than 220,000 pounds to low orbit, potentially reaching more than 330,000 pounds with future development. Meanwhile, behind the scenes, SpaceX was scouting locations in the USA to build its own launch bases, initially for the Falcon 9 and Falcon Heavy, but also anticipating the new generation of large rockets. The location chosen by SpaceX for the development of the Starship was Boca Chica, a small village in southern Texas. This area was predominantly inhabited by elderly people seeking a lower cost of living, despite the lack of basic services. The construction of the launch center began in 2014, with land leveling in 2015 and the installation of the first tracking antenna in 2016. The first propellant tanks were added in 2016, signaling the start of a series of continuous constructions. Unlike conventional practices in the space industry, SpaceX opted to build the rocket outdoors, in a sandy coastal region. The Starship Hopper, soon becoming Starhopper, began to be built under tents. With a peculiar design, including a nose cone, a lower 29-foot diameter tank, and 3 feet for support and landing gear. The Starhopper underwent cryogenic tests and pressurization with liquid nitrogen to test the welds. After a storm damaged the nose cone, SpaceX continued testing, resulting in the first flight of the Starhopper in April of 2019, reaching less than 1 foot off the ground. In July, the Starhopper flew to 66 feet high, and in August it reached 492 feet, proving the effectiveness of the Raptor engine and the viability of the design. The Starhopper was retired after these tests, becoming part of SpaceX's facilities and a historical landmark in the Starship project. SpaceX then focused on building new full-scale prototypes, such as the Mark I, 164 feet tall. Moreover, a competition between the teams in Texas and Cocoa in Florida accelerated development, with Texas completing the Mark I first. This prototype had upper and lower flaps and a more robust landing gear, prepared for a test flight of up to 3 miles in altitude. Elon Musk announced updates to the project in September, with the Starship serving as a backdrop for the news. During the SpaceX presentation, details of the Starship were revealed, including the Raptor engines in the propulsion section and an innovative heat shield designed to protect the ship during atmospheric re-entry. A striking feature were the large panoramic windows in the cabin, offering a spectacular view of space, although the technical details of their implementation were not fully disclosed. Attention turned to the Super Heavy, 223 feet tall, with 6 landing legs and 37 engines, which would use more than 720,000 pounds of propellants. The 4 grid fins, similar to those on the Falcon 9 but larger, would assist in the return to Earth. SpaceX also presented an illustrative video showing the Super Heavy executing a precise return and landing maneuver, and the Starship performing an orbital refueling. 2 months after the presentation, SpaceX tested the Mark I prototype with liquid nitrogen, resulting in a structural failure that severely damaged the vehicle. This failure attracted media criticism, but highlighted SpaceX's hardware-rich philosophy, producing multiple prototypes quickly, learning from each failure to improve subsequent designs. In 2020, the focus shifted to the serial number 1, or SN1, which was destroyed during a pressurization test. The SN3 also suffered a failure after a cryogenic test, due to an error in the defueling that compromised the structural integrity of the methane tank. After these setbacks, the SN4 successfully passed cryogenic tests and conducted the first static test. Despite several successful burns, the SN4 exploded after a static test due to a failure in the quick disconnect system. SpaceX then proceeded with the serial number 5, which passed all the scheduled Raptor ignitions and was ready to fly. This prototype, without a nose cone and with a mass simulator on top, was tested to verify if its single Raptor could move the structure in the same flight profile as the Starhopper. On August 4, 2020, the serial number 5 of SpaceX successfully flew, reaching 492 feet in altitude and causing damage to the suborbital pad. The thrust vectoring system and reaction control worked as expected, despite a small fire in the Raptor SN27 engine. The SN5 successfully landed, marking a significant advancement for SpaceX. About a month later, the SN6 repeated the SN5's feat, taking off in a stable manner and reaching 492 feet without engine problems. The landing was slightly tilted due to the disposable landing gear, designed to crumple and absorb impact. During this period, SpaceX also tested several tanks to the point of failure to understand the pressure limits they could withstand. Therefore, some SN numbers were dedicated solely to tank tests. The main focus then was on the SN8, which represented a milestone for the Starship project. After negotiations with the FAA, the flight was cleared, and the SN8 took off on December 9th for a groundbreaking flight of almost 8 miles of altitude. Equipped with 3 Raptors, the SN8 performed a sequence of engine shutdowns, followed by a controlled descent aided by upper and lower flaps. The craft did not have a complete heat shield, just samples in specific points. During descent, the SN8 executed a complex maneuver, similar to a handbrake turn, to position itself vertically for landing. We have a special video about why SpaceX uses this landing procedure and its amazing technology and engineering. Link in the description. Despite the initial success of the maneuver, one of the Raptors failed to reignite. The SN8 collided with the ground and exploded. Despite the destruction, the test was considered a significant advancement, demonstrating the viability of the Starship's design. Investigations pointed to a loss of pressure in the auxiliary methane tank as the cause of the Raptor's failure to maintain the thrust needed for a soft landing. This test paved the way for future flights and developments of the Starship project. Later, the SN9 faced difficulties, including damage during assembly and regulatory challenges with the FAA. However, the static tests were successful. The SN9's flight in February of 2021 aimed to once again test the so-called belly flop landing, a great challenge for SpaceX. During the flight, one of the engines had problems, impacting the landing maneuver and leading to the vehicle's destruction. The investigation pointed to failures in the oxygen preburner of one of the Raptors. The SN10, with improvements made from the previous versions, took off in March of 2021. The mission was almost perfect, with the engines working well and shutting down sequentially. However, one of the engines failed prematurely, and although the SN10 managed to stay balanced and land, the impact was aggressive. This flight marked significant progress, with the SN10 remaining intact after landing, despite the rough landing. The craft exploded 8 minutes later due to a helium leak that affected the engine thrust. This failure highlighted the importance of the autogenous pressurization system, which SpaceX planned to implement to replace helium use. These tests were crucial for SpaceX to understand and perfect the technology needed for the Starship's landing, a key element for its future space missions. The SN11 faced difficulties during its flight in March of 2021. Due to poor visibility, there were problems in transmitting images and telemetry, and the vehicle exploded while still in the air, after 5 minutes and 49 seconds of flight, scattering debris all over the area. The likely cause was a methane leak in one of the Raptors, leading to a critical failure during the rotation maneuver. In response to these challenges, SpaceX focused on the SN15, a more advanced version with significant structural changes and more developed Raptors. Meanwhile, the factory in Boca Chica was renamed to Starbase, reflecting its role as a major rocket manufacturing center. The SN15 was scheduled to fly on May 5, 2021. This flight was smoother than the previous ones, with the prototype reaching the desired altitude and performing a rotation, Raptor activation, and a successful controlled landing. This flight represented an important milestone for SpaceX, demonstrating significant advances over previous prototypes. The SpaceX SN15 marked a historic feat, landing successfully within the pad. After a brief scare with a fire at the base, which was quickly controlled, the SN15 remained intact. This success paved the way for future orbital flights. The SN15 is now retired at the Rocket Garden in Starbase, representing a milestone in the Starship program. Following this mission, SpaceX redirected its focus to the orbital flight, discarding the SN16, 17, 18, and 19 prototypes, which were not completed. The challenge now included developing more reliable engines and improving thermal protections, essential for ensuring the safe return of the Starship to Earth. Attention then turned to the Super Heavy, with tests on the Booster 3 or B3 prioritized. In July, SpaceX conducted a successful static test with the B3 using 3 Raptors. Concurrently, construction of the orbital pad progressed, including the assembly of a 480-foot integration tower and a launch table capable of supporting the Starship and Super Heavy set. Interestingly, the ground tanks at the orbital pad were built using the same techniques and materials used in the Starship, demonstrating SpaceX's expertise in handling stainless steel under high pressure. The complex includes 8 tanks for various consumables, including liquid oxygen, methane, nitrogen, and water. The integration tower, part of what was dubbed Stage 0, included an innovative landing system that dispensed with the traditional landing gear of the Starship and Super Heavy, significantly reducing the mass of the vehicles. This system of catch-arms in the tower would help maneuver the prototypes to the launch table and position them over the Super Heavy, optimizing the process and reducing risks. The first vehicle to be tested at the orbital pad was the Booster 4, equipped with 29 Raptors. This prototype, which was not yet ready for flight, was used to test compatibility with the launch table and to assess the placement of the Starship on top of it, representing another significant step in the development of the Starship program. The Starship 20 prototype from SpaceX brought significant advances to the project. Fully covered by a heat shield composed of high-temperature resistant ceramic hexagons, the S-20 was prepared to face the intense heat of atmospheric re-entry. This simplified design, with fewer geometric shapes than the Space Shuttle, facilitated the assembly and production of the protections, which were manufactured in Florida. The S-20 also introduced the Raptor vacuum, optimized versions of the Raptor engines for operation in space. With a larger nozzle but without major structural changes, these engines were installed on the prototype, along with the sea-level Raptors. On August 6, 2021, the Starship 20 was mounted on top of the Super Heavy Booster 4, demonstrating to the world the viability of the largest rocket in history, measuring about 394 feet in height. The assembly of the S-20 and the B-4 was a milestone, watched live by many enthusiasts. However, the assembly was brief, and the B-4 was later taken to the orbital pad for cryogenic tests. During this period, SpaceX worked on improvements to the rocket, including aerodynamic protections and modifications to the launch table. A significant challenge for SpaceX arose with the programmatic environmental assessment of the project, submitted to the Federal Aviation Administration, FAA. The documentation, necessary for orbital flights, covered detailed environmental and operational impacts. The public hearings related to this assessment, held online due to the pandemic, brought a variety of opinions, from support to criticism of the project. Meanwhile, SpaceX began testing the S-20, including the successful ignition of a Raptor vacuum in October 2021. Despite some challenges such as the falling off of heat shields after static tests, the refractory design of the shield provided sufficient protection. These advances and tests were crucial steps in preparing the Starship 20 for the anticipated orbital flight. The most comprehensive test of the Starship program occurred on November 12th, when the Starship 20 successfully activated all 6 of its engines. This test was fundamental for simulating launch conditions, albeit on a reduced scale. However, the heat shields continued to be a concern, with SpaceX constantly improving the methods of attachment to prevent detachment. In February 2022, the S-20 and the Booster 4, or B-4, were assembled for a project update, highlighting significant advancements. The Starship maintained its specifications of 164 feet in height, 29 feet in diameter, and the capacity to carry a payload between 220,000 and 330,000 pounds to orbit. The Super Heavy reached 226 feet in height, maintaining the same diameter, and became the most powerful rocket ever built. In this update, Elon Musk presented the Raptor 2, an improved version of the engine, more efficient and economical. With a cleaner design and fewer visible pipes, the Raptor 2 achieved a thrust of more than 500,000 pounds. This advancement allowed SpaceX to accelerate production to 1 Raptor engine per day, an unprecedented capacity in the aerospace industry. SpaceX was also selected by NASA to provide the human landing system, which would take astronauts from lunar orbit to the surface in the Artemis 3 mission. But this contract of almost $3 billion generated controversy, especially with Jeff Bezos's Blue Origin, which contested the result and accused NASA of favoring SpaceX. Then, despite these disputes, the contract remained with SpaceX, which also benefited from additional funding for Artemis 4 missions. With progress on the Starship 20 and the Booster 4, focus shifted to the Ship 24, an improved version equipped with the new Raptor 2 engines. This development occurred even with the FAA's environmental license still pending, an obstacle that delayed progress to orbital flight. In June, the FAA approved the environmental license for the operation of Starbase, with some minor reservations. However, the license for the Starship's orbital mission was still pending. The Super Heavy Booster 4 was replaced by the Booster 7, with improvements in manufacturing and new engines. The B-7 faced setbacks, including the implosion of a propellant transfer pipe during a cryogenic test, but was repaired and returned to testing. An explosion under the base of the launch table during a spin prime of the B-7 in July caused significant damage, leading SpaceX to introduce improvements to the pad and the gas dispersion system. Continuous tests of the B-7 and the Ship-24, including ignitions and spin primes, laid the groundwork for an orbital flight. In February 2023, an impressive test activated 33 Raptors of the B-7 simultaneously, demonstrating the power of the largest space vehicle built by humanity. However, by the end of 2022, no orbital flight had been conducted, causing disappointment among enthusiasts. Then, in early 2023, the intensification of tests renewed hopes. In April, the Ship-24 and the B-7 successfully passed a full cryogenic test, leaving only the FAA's flight license pending. Despite the delays and uncertainties, the environmental approval and the interest of NASA and the Department of Defense indicated an eventual release of the license. Rumors suggested that NASA's Space Launch System might be launched first with the Artemis 1 mission, but these claims were not confirmed. Meanwhile, SpaceX was preparing for the next step, awaiting final authorization to launch the largest rocket in history. Then, on April 14th, the Federal Aviation Administration granted the final authorization for the flight of Starship and Super Heavy, setting April 17th as the launch date. The mission included the controlled sacrifice of both vehicles, with the Super Heavy performing a return maneuver after 3 minutes of flight and Starship proceeding almost to orbit before descending for a landing in the sea near Hawaii. In the final moments of the countdown, the tension was palpable both at SpaceX and among global viewers. The launch would represent a milestone in the history of space exploration, with a rocket larger and more powerful than the legendary Saturn V. However, an issue with the pressurization valve of the Super Heavy led to the postponement. SpaceX took the opportunity to collect valuable data. A new attempt was scheduled for April 20th. Then, on the launch day, the countdown was momentarily stopped in the last 40 seconds for final checks, but soon resumed. The launch was followed globally, with the expectation of witnessing the largest rocket ever built finally fly. The 33 Raptors of the Super Heavy were activated, generating a shockwave that propagated for miles. The rocket's ascent was marked by failures in some engines and a fire at the base, indicating a serious problem. Despite the difficulties, the Starship continued its ascent, facing additional challenges and the loss of more engines. But then, it seemed to be completely out of control. When it became clear that the mission could not continue, SpaceX activated the flight termination system, destroying the Starship in the air. The launch also resulted in significant damage to the orbital pad, with the destruction of the base concrete and damage to structures and equipment nearby. Criticism was raised against SpaceX for not installing a flame deflector, a crucial component for a rocket of this size. Elon Musk admitted that the decision not to install the deflector, which was delayed, was based on incorrect data from static tests of the Super Heavy. Then, the pad repair operation was initiated, with the expectation that it would take months to prepare for a new flight. Despite the criticism and challenges faced, the flight was a milestone in space exploration, with the promise of more advances and spectacular flights in the future. After 212 days of repairs and more than 1,000 upgrades and iterations, SpaceX attempted the second integrated test flight of the Starship launch vehicle, showcasing significant improvements. But this latest test displayed a markedly different outcome. Moments before launch, with the sunrise as a backdrop, the rocket was filled with approximately more than 10 million pounds of propellant. The countdown resumed after a brief hold at T-minus 40 seconds, just like the previous launch. And then, all 33 Raptor engines ignited and lifted Starship into the air within seconds. This was significantly faster than the first integrated test flight. The vehicle accelerated effectively, with all 33 Raptor engines functioning properly, a stark contrast to the multiple engine failures in the previous flight. By 1 minute and 12 seconds, Starship had reached max Q, the point of peak mechanical stress, traveling at around more than 900 miles per hour and reaching an altitude close to 9 miles. These numbers continued to rise until the significant milestone of stage separation at 2 minutes and 40 seconds. But the first visible error in the launch occurred shortly after, with a small explosion and leaking fluids visible at 3 minutes and 15 seconds. This led to the booster experiencing an explosion at 3 minutes and 20 seconds. Meanwhile, the Starship upper stage continued its ascent, 4 minutes into the flight, it was traveling over more than 4,600 miles per hour at an altitude of 73 miles. The upper stage maintained this trajectory until around 8 minutes into the flight, when ripples in the atmosphere suggested a possible explosion, and all 6 engines ceased functioning. Then it was later revealed that the second stage explosion was due to the activation of the flight termination system, though the exact cause remains unclear. This marked the end of Starship's second integrated test flight, a significant step forward despite the explosive ending. But SpaceX's approach involves rapid construction and testing, where even failures provide valuable data. This second flight debuted several enhancements, including a hot stage separation system, a new electric thrust vector control system for the Raptor engines, reinforced pad foundation, and a water-cooled steel flame deflector. The third test flight of SpaceX's Starship took place on April 14, 2024, following months of meticulous preparation and high anticipation. At liftoff, once again all 33 Raptor engines on the Super Heavy booster ignited, and liftoff was even faster than the second flight test. At 2 minutes and 40 seconds into the flight, stage separation occurred, utilizing the innovative hot stage ring to optimize velocity and increase payload capacity by 10%. Then, the Super Heavy booster began its descent trajectory to attempt a splashdown into the sea. But in the last stage of the descent, technical issues arose, causing the booster to crash into the sea after an unsuccessful engine restart attempt. The upper stage proceeded on its trajectory toward a near-orbital flight. Although a planned reignition of one Raptor engine for re-entry was scheduled, it was deemed unnecessary for this mission. Instead, the primary focus shifted to testing the heat shield, which provided breathtaking visuals of plasma forming around the spacecraft during re-entry. During re-entry, Starship maintained a 40-degree angle of attack to dissipate heat. However, at approximately 48 minutes into the flight, intense heat concentrated on the nose cone, resulting in the detachment of several heat shield tiles. The spacecraft ultimately lost telemetry at an altitude of 40 miles and a speed of more than 15,000 miles per hour. SpaceX later confirmed the activation of the flight termination system. But despite the destruction of the vehicle, the test was deemed a success by SpaceX. Key objectives, including liftoff with all 33 engines, passage through max Q, and refinement of stage separation dynamics, were partially achieved. Then, the extensive data collected during the flight informed significant design revisions for future tests. The fourth test flight of SpaceX's Starship occurred on June 6, 2024, following months of rigorous engineering upgrades and meticulous planning. This mission sought to push the boundaries of Starship's reusability and durability. At liftoff, the ascent was smooth, but 2 minutes into the flight, the mission reached a critical milestone: stage separation, utilizing an upgraded separation mechanism designed to improve reliability and efficiency. The new hot staging technique was successful, and the booster and the Starship upper stage, Ship 29, parted ways at an altitude of 46 miles. Following separation, Booster 11 initiated its return sequence. Using its grid fins for stability and control, the booster performed a series of burns to align its trajectory for descent. At T+7 minutes, it made a groundbreaking soft splashdown in the Gulf of Mexico, marking the first successful recovery of a Super Heavy booster. Meanwhile, Ship 29 continued its ascent, reaching its planned apogee of 132 miles. This phase focused on collecting data on structural integrity and system performance in near-space conditions. Re-entry began shortly after, with Ship 29 encountering peak heating and aerodynamic stresses. The spacecraft maintained a stable 40-degree angle of attack, dissipating heat across its surfaces. But then, the heat from re-entry was so intense that it began to damage its forward flaps, some heat shield tiles, and the onboard cameras. Tension rose as the live video stream kept crashing and restoring. The ship was getting more and more damaged and could explode at any second. Then, fortunately, Ship 29 successfully completed its descent and executed a controlled splashdown in the Indian Ocean, showcasing the spacecraft's ability to endure re-entry forces. This test marked critical milestones for SpaceX, including the first successful booster splashdown, the first re-entry of a Starship vehicle, and invaluable data on system durability. Then came Starship Flight Test 5. This test flight marked one of the most amazing and groundbreaking milestones in the history of space exploration. On October 13, 2024, the mission began with a flawless liftoff from SpaceX's Starbase in Texas. The Super Heavy booster, powered by 33 Raptor 3 engines, propelled the Starship upper stage to an altitude of approximately 43 miles. The ascent was remarkably smooth, with all systems performing nominally. Stage separation was executed with precision once again. But the highlight of the mission came during the return of the Super Heavy booster. Using its grid fins for precise navigation, the massive rocket executed a controlled descent back to the launch site. As it approached the ground, the launch tower's mechanical arms sprang into action. In a breathtaking maneuver, the arms securely captured the booster mid-air, eliminating the need for a traditional landing pad. SpaceX achieved an unprecedented feat, the first mid-air capture of a rocket booster using the launch tower's Mechazilla arms. This accomplishment not only cemented SpaceX's leadership in reusable rocketry, but also redefined the possibilities of aerospace innovation. We have a detailed video about the engineering behind this amazing feat. Link in the description below. While the booster was being recovered, the Starship upper stage continued its mission, reaching an apogee of 132 miles. Following a controlled descent, it splashed down in the Indian Ocean as planned, concluding the test and collecting valuable data to refine future missions. The success of Flight Test 5 underscored significant advancements in SpaceX's iterative design approach. From flawless stage separation to the precision mid-air capture of the booster, every aspect of the mission highlighted the company's commitment to pushing the boundaries of rocket engineering. The integration of the Mechazilla arms into the recovery process was a bold and transformative innovation, dramatically reducing turnaround time and setting a new benchmark for cost-effective and sustainable space exploration.